So topic for the day is, first we are going to discuss STP protection. So first of all, if I will talk about STP protection, so the first feature that we have for a spanning tree protection is root guard. Root guard. Now anyone want to explain root guard? What is root guard? What is root guard? Yes, Mohan. What is root guard?
So, as I know, root guard is protecting a root guard means
On which
any
switches we
other
need to
switch
enable root
can't.
guard?
It's on core switch, sir.
On core switch means on root bridge.
Yeah.
And
Yes,
on
sir.
which port? Root guard should be enabled on
Port,
DP
yeah.
port. It should be
Okay.
enabled on DP port so that
DP
root
port.
bridge will put root guard enable interface in inconsistent state if it will receive any superior BPDO. Let me make you understand with one example. Let's say here I have one switch, fine, and this switch is connected with another switch, and this switch is connected with one another switch here. In this scenario, switch 1 is my root bridge. Switch 1 is top switch. This is switch 1. Switch 1. This is switch 2. And let's say same like switch 1 is using MAC address 0A and switch 2 MAC address is 0B and switch 3 MAC address is 0C. Okay. So if switch 1 MAC address base MAC address is 0A and switch 2 base MAC address is 0B and switch 3 base MAC address is 0C, then which switch will become root bridge? Switch 1? Switch 1 will become my root bridge,
Yes, sir.
yes or no?
Yes.
Okay,
Yes,
so
sir.
if this switch is root bridge, root, then all ports of this switch will become what? DP. This port will be DP.
Yes, sir.
This port will be also DP.
Yes.
And as you all know, what is the use of DP? DP port is the port which transmits superior BPDO. Yes or no? This port will be the RP port. This port will be also RP port. And this port may be DP. Yes, definitely this port will
DP.
be DP. And this port will be alternate.
Alternate.
Yes, am I right? Till
Yes, sir.
here everything is clear. Hope it is clear to everyone because we had discussed lots of time this convergence. You know, root bridge election or root port election or DP election, STP election, we have discussed many times. So this should be clear to everyone. Now, in this scenario, as you all know, DP port transmits superior BPDU. So root bridge will transmit superior BPDU from their both interface, like from their both DP port, from this port and from this port. It will send superior BPDU. After that, switch 2 will relay that superior BPDU from this port. Yes, let's say one attacker will attach their switch with switch number 3, let's say, or with switch number 2, with any switch. If an attacker will attach their switch, and here I am saying attacker will attach their switch, but they can attack with the help of PC as well, right? From PC also we can send BPDU with lower priority. Let's say attacker have put their switch here and they have set priority 0 here, and they will connect this switch to, let's say, switch number 2. Now what will happen? This port will become what? DP, yes or no? And now switch is receiving superior BPDU on which interface? On this interface. So this interface will become now RP, yes or no? This port will be become DP, yes or no? And from this DP port it will send superior BPDU. When root bridge will receive this superior BPDU, this port will become what? RP. Now root bridge is this switch, not this switch, yes or no?
Yes.
So anyone can send the BPDU to root bridge with lower MAC address, right? After that, your root bridge will couldn't be root bridge. Yes or no?
Yes, sir.
If
Yes, sir.
someone have sent the BPDU with lower priority to root bridge, then root bridge is not my root bridge now. So to protect this type of attack, we have a feature called root guard. Now when you
Good
will
God.
enable root guard on this two port, and if root guard enable interface will receive superior BPDU, it will immediately put that interface in inconsistent mode. And inconsistent mode is similar like blocking state. Getting my point? So any port where root guard is enabled cannot receive superior BPDU. So I want that this is my root bridge. This switch should be root bridge always. So this switch should not receive any superior BPDU on their interfaces. Yes or no? So on these two interface, we should enable root guard feature. Is it clear?
Yes, sir.
Mohan, to you and Suresh.
Yes, sir.
Okay. Second scenario. And root guard should be enabled on trunk DP port. Like if here PC is connected, one PC is connected over here with switch number 2. So the port which is connected with PC of switch 2 is also DP. So on that port you will not enable root guard. Root guard should be enabled on trunk DP port. Like between switches, link is configured as trunk. Here we will enable port fast, and here we have other feature for access port. On access port we are not using root guard feature to protect. Okay, and what is the command? Can anyone tell me what is the command to configure root guard? If you want to configure root guard, like in here I have one topology, I think. Yeah, I have one topology, this topology. Okay, let's say in this topology which switch is root bridge? Switch number 1 is my root bridge.
Yes, sir.
So these
Yes.
are DP port. Now I am going to enable root guard on switch number 1, means on both port of switch number 1, and then I will set priority 0 on, let's say, switch number 3. So switch 3 will send superior BPDU to switch 1, and switch will put that interface in inconsistent state. If you want to see, I can show you as well practically. Tell me, do you want to see?
Sir, if that port will be in inconsistency, then
Yeah.
the root bridge will remain switch one only, or how, sir?
No, if you then you have to correct that interface. You have to run shutdown command and then no shutdown command, but still switch 2 will be your root bridge. Switch 2
Okay.
will be your root bridge, okay?
Switch one, no, sir.
Yeah, sorry, switch 1. Extremely sorry.
Okay.
Switch 1 will be a still root bridge switch. Do you want to see
Okay.
practically?
It remains. Yes, sir. Yes, sir.
Okay. Then what I am going to do here, first of all, the link between switches should be, I'm going to configure as trunk. The link between switches is trunk, and if you will not configure trunk, then also we don't have problem, right? It will work. E0/0 and E0/1, I am going to say switch port interface range and switch port mode dynamic desirable. Automatically link between switch 1 and switch 2 and switch 1 and switch 3 will be configured as trunk. So interface trunk, you can see these two interfaces are trunk, and between switch 2 and switch 3 also I am going to configure link as trunk. So let me take you to switch number 2, and on this switch, let's say I am going to say interface E0/1 and switch port mode dynamic desirable. Done. Now I am going to enable, see, if you will check which switch is root bridge, now you can see root bridge switch is the switch whose MAC address is this one, and this is the MAC address of switch 1. Fine. So now switch 1 is my root bridge. On root bridge, I am going to enable root guard feature, because if root guard feature is not enabled on switch number 1, and if you will set lower priority on switch number 2, then switch 2 will become root bridge. But if root guard is enabled, let's say here I am going to say interface range E0/0 and E0/1. On these two interface I am going to enable root guard. So command is a spanning tree guard root. This is the command. Fine. Now you can see, so a spanning tree. Both port of this switch is DP and state is in forwarding. Now I am going to do one thing. On switch number 2, let's say I am going to set lower priority. A spanning tree for VLAN 1, and I am going to set, let's say, priority 0 over here. Okay. And now if you will check switch number 1 interface, you can see the log message as well, by the way. And you can see, so a spanning tree port is in blocking state, yes or no? And why port is in blocking state? Port is in consistent state. Okay,
Sir,
but
why both
still
the ports, sir? Only one port.
both port.
It is reaching from.
No, switch 3 will also send, na. Switch 2 will forward BPDU to switch 3, and switch 3 will relay to switch 1 also.
Okay.
Yes or no? It will receive, switch 1 will receive superior BPDU on both interface, on this interface also and on this interface also.
Yeah. Got it.
Got it?
Yes, sir.
But so a spanning tree, you can see, but still this switch is root bridge.
Good.
Okay. Now I am going to say no to this command. No to this command, and here again, see, this port is in blocking state. Still this port is in blocking state. So you have to run sut command and then no sut command on this port. Then port will come in forwarding state. What is happening here? Do so spanning tree. Now you can see port is in learning state, and after some time it will come in forwarding state. Or if you want to quick result, then you can run shutdown command, then no shut command. Okay. Let me discuss next protection. That is, next
So,
one is,
sir,
yeah,
sir, this root guard command should be enabled under each interface, correct?
yeah, all
On
trunk DP port.
all trunk, yes, that's what I'm telling. All DP, trunk DP, and under each individual port we need to run this.
Yes, exactly.
Okay.
Like
Sir,
here
only
also
on
you
root
need to
bridge
enable.
DP ports. Okay. That was because
Yeah,
if we have 50, 100 switches, we have to enable it in all switches DP ports.
exactly.
Oh,
Okay.
okay.
After that, next one is which one?
BPD. BPD guards.
BPDU guard. Okay, before BPDU guard, let me discuss loop guard.
Oh, loop guard. Oh.
Loop guard. So anything about loop guard, if anyone know? Hmm? Don't know, guys?
I read it, sir, but I forgot. I'm not getting it into
Okay.
mind, sir, right now.
Okay, actually this is used to prevent loop. How loop can form? First, try to understand. Let's say, suppose because of congestion on the link between switch 1 and switch 3, because there is congestion on link, or because of, there are lots of reason, because of that switch can be not receive BPDU from switch number 1 on this port. Switch 3 is expecting BPDU after every 2 seconds on this port. Yes or no? Yes or no?
Yes.
Yes, it
Yes,
is
sir.
expecting a BPDU from switch number 1 after every 2 seconds. But let's say because of any reason it is not receiving BPDU on this port. If it is not receiving BPDU on this port, then what will happen? It is receiving one BPDU over here. Alternate port can receive BPDU but cannot send
BPDU.
BPDU. Yes or no? So it is still receiving BPDU over here. So that BPDU will become best. Yes or no? Superior. If switch 3 will stop receiving BPDU on their RP port, then this port will become RP. Right? That means I am receiving now superior BPDU over here. And switch 3 will start relaying that BPDU to switch number 1. Yes or no? Definitely yes. We all know that when switch 3 will receive BPDU on this RP port, it will relay that BPDU from this port, and this port will become DP. Right? Now what is this? This is loop. Root bridge is sending their BPDU to switch number 2, and root bridge is receiving same BPDU from switch number 3. Right? It is receiving same BPDU from switch number 3. This is loop. Yes or no? So just to avoid this loop, we have a feature called loop guard. To prevent loop, enable loop guard on all RP trunk port. On all RP trunk port, or you can say all trunk RP port. Now what loop guard will do? What loop guard will do? If loop guard enable interface send BPDU, let's say here we have enable the loop guard on this port because this is my trunk RP port, and if this port will send any BPDU, then again then switch will put that interface in inconsistent state.
Inconsistent.
What I am saying, if loop guard enabled interface send BPDU, then switch will put that interface in inconsistent state. Okay, so this feature should be enabled on RP port, because RP port is the port which receive BPDU. RP port should not send BPDU. Yes or no?
Yes.
RP port should
Yes,
not
sir.
send BPDU. So that's why we will enable this feature, loop guard feature on RP port. Guys, just I am going to give you command, because practical is same. Why we will perform practical of each protection? Yes or no? Just I am going to tell you the command. What is the command to enable it? And hope it is clear to you that you will enable this feature only on RP, only on trunk RP port, so that RP port should not be able to send BPDU. If RP port is sending a BPDU, then it will put that port in inconsistent state. That's it. Fine. So here in this scenario, on which port and on which switch you will enable this feature?
In switch number 2, E0/0, sir.
Switch 2 E0/0 and
0. Yes, sir.
E3
Switch 3, 0
0/0.
slash 0.
Yes,
Yes.
very good. And
What about
command,
alternate port, sir?
no, all alternate port you will not enable it, this
Okay.
feature.
Okay.
Okay, and command will be see interface E0/0, and here you can run a spanning tree loop guard.
Loop.
Loop guard. I think this command,
Guard.
guard loop, guard loop. Yes,
Yes.
this is the command. Okay, we can enable this command on RP port. After that, if this feature is enabled on RP port, and if then RP port need to send BPDU, then switch will put that interface in inconsistent state. Okay, now next protection is BPDU guard. So what is BPDU guard? This
Any
time,
port which receives BPDU, actually, sir, BPDU guard we will enable on access ports, like end device connected ports.
exactly, very good,
If that port receives say BPDU, that port will be in inconsistent state.
very good. So this BPDU guard should be enabled on access port. Like again, this is my topology.
Sir, one query.
Hmm.
So, say for example, it is to be uh, configured on access ports. But say for example, we have configured port fast on all access ports. Then also, do we need to configure it
Yeah,
like
port fast. You know what is the use of port fast? Port fast is used to bypass the learning and listening state
STP? Yeah, STP states.
only. Port fast cannot help you to protect a spanning tree protocol or a spanning tree
Okay,
topology.
okay.
Okay.
It reduces the convergence time.
Yeah, port fast is for convergence. So here, let's say I have some PC and devices. So as you know, end devices should not be able to send. Why end devices will send? BPDU.
Basically, it is one kind of security feature only, correct?
Yes, correct. Like here we have 3 PC. So these are access port of switch 2. So on these access port, BPDU guard should be enabled. Okay, so enable BPDU guard on access port so that if switch will receive BPDU on BPDU guard enable interface, it will put that interface in error disable state. It will put that interface in error disable state. Okay, let's say in this topology you can see an interface like E0/0, E0/1. Switch is forwarding BPDU from E0/1 and it is forwarding BPDU from E0/2 also. And if E0/2, if I will connect E0/2 with one switch and that switch will send BPDU, let's say there I have configured my lower priority, so that switch will start sending BPDU to switch number 2. So this port will be in error disable. Okay, what we can do here, just to show you on switch number 2, I am going to do one thing. I am going to enable this feature on, let's say, switch 2, uh, switch 2, which interface E0/0, because E0/0 is receiving BPDU. Okay, so interface E0/0, and I am going to say uh, a spanning tree. What is the command? A spanning tree, I think BPDU guard
BPDU guard.
enable. Yes, BPDU guard enable, and show a spanning tree. You can see the log message as well. So a spanning tree. E0/1. Are you able to see E0/1 interface here? No. And so interface, we can check status, let's say, and error disable. Show me the status of error disable port. So you can see 0/0 is there. Status is error disable. Reason is BPDU guard. Reason is BPDU guard. Okay. So BPDU guard enable interface, whenever BPDU guard enable interface will receive BPDU, then switch will put that interface in error disable state. I am going to say no. I'm going to remove this command from this interface, a spanning tree. BPDU guard enable, say no to this, and shut down, and then no shutdown, and so a spanning tree. Done. This port is now in listening state. Soon it will come in learning and then in forwarding. Is it clear? Is there any more protection, guys, feature available? Yeah, we have one more, that is not STP protection, by the way, but we can say BPDU filter. BPDU filter. This this feature is used to stop BPDU on access port. Like you can see switch A, switch 2. Switch 2 have some computers, and switch 2 is sending BPDU from all interfaces. So if you want to stop like passive interface configuration in routing, if you want to stop BPDU on access port, that switch, so we can tell to switch number 2, please do not send BPDU on access port from access port. With the help of this feature, we can enable this feature on access port. Okay, fine guys, is it clear to all? STP
Sir,
protection.
how we can utilize this, sir? BPDU filter.
BPDU
Why
filter
it
should
should
be
not?
enabled. So next topic is types of spanning tree. Anyone? How many types of spanning tree protocol we have?
So one is common spanning tree, then there is PVST, PVST plus, then rapid spanning tree,
Till now we have
then
discussed which protocol?
so CST,
Till now we have discussed CST. Very good. After that, Cisco have launched one protocol, that is PVST.
PVST,
After that, PVST is not compatible with CST. So that's why Cisco again come up with
PVST
PVST
plus,
plus. Then
then
RS,
RPVS, RSTPS,
RSTP for non-Cisco devices, and for Cisco devices
RPVST,
RPVST,
Plus.
and then
MSTP.
RPVST plus. RPVST
Okay,
is replaced by
PVST plus.
RPVST plus, and then seventh one is MST. Okay, so if you have understand CST, you can understand these all. These all are based on CST only.
PVST.
Let me make you understand with one diagram in uh, GNS3 in EVNG. Here I have one topology. Guys, in this topology, tell me which switch is root bridge.
Switch one.
Switch 1 is root bridge. Very good.
Yes,
And both ports, all ports of switch 1 will be DP,
DP.
right? And switch 2, which port will be RP and which port will be in blocking state?
E 0/0 will be RP. E 0/1 will be alternate.
Alternate. Very good. And logical topology will be, how many logical topology will be there? Oh my god.
Only
Only single logical topology will be there,
yes,
Yes.
right?
point to point connected.
Yes. So we will have switch 1, switch 2. Between switch 1 and switch 2, E0/0 link will be used, and other this link is in blocking state. We have 2 PC over here. This is my logical topology, right? Let's say here we have 100 number of VLAN, 100 VLAN 1 to 100, and here also we have 100 VLAN 1 to 100. So for all VLAN, all switches going to use this link only. Switches is going to use this link only. So there is no load balancing. Let's say what I want to perform load balancing over here. We have 100 VLAN. I want to use upper link for VLAN, let's say 1 to 50. For VLAN 1 to 50, I want to use this link. And for VLAN 51 to 100, I want to use this link, lower link. This is not possible in case of CST, common spanning tree protocol. Why this is not possible? Because common spanning tree protocol run single instances for all VLAN. Doesn't matter how many VLAN you have on switches. STP instances will be only one. Yes, getting my point? Load balancing is not possible. What I want, that between switch 1 and switch 2 there should be two logical topology. For VLAN 1 to 50 this link should be active, 0/0 and 0/0, and for VLAN 51 to 100 0/1 should be active link for VLAN 51 to 100. So I want to perform load balancing. Let's say I want to forward traffic for some VLAN from upper link and traffic for some VLAN from the lower link. I want to achieve load balancing here. That load balancing is not possible in case of common spanning tree protocol, because common spanning tree protocol run single instance of STP for all VLAN. Okay. So that's why to achieve load balancing, Cisco come up with PVST. PVST stands for per VLAN spanning tree protocol. Now spanning tree instances depends on the VLAN. If you have 100 number of VLAN on switches, then STP is going to run 100 number of instances. Getting my point? So if on this switch I am running PVST protocol, then switch is going to run 100 instances, one for one VLAN. So there is 100 VLAN, so there will be 100 number of instances. And for some VLAN, we can increase the cost of, let's say, this interface. Then what will happen? In this scenario, if I will increase the cost of this interface for, let's say, VLAN 51 to 100, then for VLAN 51 to 100, this port will become what? RP, yes or no? And this port will be still RP for VLAN 1 to 50, yes or no? So this is load balancing. We can achieve load balancing in case of PBST. And by default, the spanning tree protocol which is running on switches is, which protocol is running by default on Cisco devices?
RPVST.
Are you sure? How to check?
So spanning tree
PVST, sir.
summary.
So spanning tree summary. Which protocol is running?
PVST. Okay.
PVST. This is not PVST. This is PVST
PVST
plus.
plus, yes.
Guys, the difference between PVST and PVST plus is PVST is not compatible with CST and PVST plus is compatible with CST. So let's say this is switch 1 is Cisco devices and switch 2 is non-Cisco devices. So on non-Cisco devices we are running what? CST protocol, let's say, common spanning tree protocol, and on Cisco means Cisco devices we are running PVST. So PVST is not compatible with CST. They cannot exchange the STP instances. But PVST plus is compatible with CST, and by default PVST plus is running on all Cisco devices. So here if I want to achieve load balancing, let me first create VLAN. So spanning tree. Now we have only one VLAN, and for VLAN 1 these all ports are DP. These all ports are DP, and on switch number 2 also you can see so a spanning tree for VLAN 1 all ports are means this port is RP 0/0 and this port 0/1 is alternate port, and these two ports are DP because these two ports are connected with PC. Fine. Now I am going to first configure the link between switches as trunk. Interface range E 0/0 to 1 and switch port mode dynamic desirable. Now link between switches is trunk. So interface trunk. Right. Now I am going to create some VLAN over here. VLAN. And if you want to propagate VLAN, then you have to configure what? VTP domain name. So let me set domain name also. VTP domain name is CCIE. Now on switch number 1 also you can verify VTP domain name. So VTP status. VTP domain name is
CCI.
okay, and so interface trunk. So trunk is there, that's why VTP is propagating the information. Now I am going to create VLAN 2 let's say 10. Okay, we have created 10 number of VLAN and so a spanning tree protocol. By default, as I told you, that PVST is running. That means switches will have 10 number of instances. You can see this is the instance for VLAN 1. This is the instance for VLAN 2. This is the instance for VLAN 3. This is the instance for VLAN 4, for VLAN 5, for VLAN 6, for VLAN 7, for VLAN 8, 9, and 10. For all VLAN, now switches are maintaining a separate STP instance. In the same way, switch number 2 also. So, a spanning tree protocol. You can see instance for VLAN 1, for VLAN 2, for VLAN 3, 4, 5, 6. For all VLAN, it is going to maintain a separate STP instance. Now I want to achieve load balancing because by default for all VLAN you can see this port is, I am on which switch? On switch number 2. So E0/0 is DP and E0/1 is DP. How it's possible? This port should be RP na. For VLAN 2, both ports are, this is my switch 2. This is 0/19 port number and this is 0/20 port number. Okay, let me access the device. Hope you guys is here. First, I am going to down all the interfaces, then I will up only 0/90 and 20. Interface range F1/0/1 to 24, say shutdown, and on switch number 2 also. Interface range F1/0/1 to 24, say shutdown, and on switch number 1 interface range F1/0/19 to 20, say no shutdown. On switch number 2 also interface range F1/0/19 to 20, say no shutdown. Okay, and so CDP neighbor, just wait for some time. So CDP neighbor, Okay, so switch 1 is never on 0/90 and 20. I am going to configure this link as trunk first. So interface range f1/0/19 to 20 and switch port mode dynamic desirable. Okay, and so interface trunk. So interface trunk. Okay, both link is configured as trunk. Now let me verify the VLAN. So VLAN brief. So there are some VLAN. First of all, let me delete the VLAN. And so VTP domain name, VTP status. So here domain name is CCNA and on switch number 2. So VTP status. VTP is already configured, domain name is CCNA. So that's why you can see VLAN is synchronized. On both switches, we have VLAN 10, 100, 101, and here also I think so we have same VLAN. Yeah, VLAN 1, VLAN 100. I am going to remove this VLAN. Say no VLAN 22. Let's say 22900, and so VLAN brief. So now we don't have VLAN over here on switch number 2. So VLAN brief. I don't have VLAN here. Now I am going to create VLAN 1 to 10. So VLAN 2 to 10. So VLAN brief. First of all, you can see VLAN 1 to 10 is there, right? On switch number 2 also. So VLAN brief, we have VLAN 2 to 10. And on switch number 1 or on switch number 2, on any switches, if you will run so a spanning tree protocol, you can see we have multiple instances. Like so a spanning tree for VLAN 1. So this is instances for VLAN 1. So a spanning tree for so a spanning tree for VLAN 10. So this is a spanning tree for VLAN 10. This switch is not root bridge, switch 2 is root bridge, but I want switch 1 should be my root bridge. So on switch number 1 I am going to set priority 0. A spanning tree for a spanning tree priority. Here I need to define what? A spanning tree then VLAN. So I want to configure priority for all VLAN to 0. How I will configure it? How I will configure it, guys? Tell me. Here we have lots of options. For VLAN 1 to 10. For VLAN 1 to 10 and then priority 0. So now root switch 1 will become my root bridge for VLAN 1 to 10. So a spanning tree for VLAN 10. So you can see both interface of this switch is DP. And on switch number 2, so a spanning tree for VLAN 10. This switch is non-root bridge switch. So 0/19 is RP and 0/20 is block. I want to utilize both link. As I told you that for VLAN 1 to 5, I want to use upper link 0/19, and for VLAN 6 to 10, I want to use lower link. So on switch number 1, I can change priority for VLAN 5 to 10 on 0/19 link. I will increase the priority. What is the by default priority? Or I can increase the cost. What is by default cost on fast Ethernet link? 19. So I will set, let's say 20. Interface F1/0/19. A spanning tree cost 20. Okay, and so okay, spanning tree cost 20. I have set for all VLAN. First of all, let me remove this command. Interface F1/0/19 and say no to this command. Otherwise, for all VLAN switches, will start using 0/20 port. Okay, and I am going to say spanning tree for VLAN 6 to 10 priority, sorry, cost 20. So now you can see, so a spanning tree for VLAN 1. For VLAN 1, 0/19 is RP. Am I right? 0/19 is root port and 0/20 is blocking. Right? For VLAN 2 also, 0/19 is RP and 0/20 is blocking. But for VLAN 10, RP is 0/20. That means for VLAN 6 to 10, VLAN 6, 0/20 is RP. For VLAN 6 to 10, 0/20 is RP, and for VLAN 1 to 5, 0/19 is the RP. So we are achieving load balancing here, yes or no? Let's say on switch number 1 we have some computer. R1, I am going to access all switches. R1, here I all routers. R2, EM123, R2, this is my R2, and I'm going to access R3 and 4 also. This is R3, and let me access R4 also. Set. This is my R4. Let me make you familiar with the topology, which topology I am going to design here in rack. I am going to connect R1 here, R1, R2, R3 here, and R4 here. R4. Let's say this is 0/0, 0/1, sorry. This is 0/2. This is 0/3. And this is 0/4. Okay. Router 1 interface is 0/0, router 2 interface is 0/0, router 3 interface is 0/1, router 4 interface is 0/1. Here let's say IP address is 10.1.1.1. Here IP address is 20.1.1.1. Here IP address is 10.1.1.2. Here IP address is, let's say, 20.1.1.2. And router 1 is member of VLAN, let's say 5. VLAN 5, This router 2 is member of VLAN 10. This is again VLAN 5, and this interface router 4 is in VLAN 10. Okay, I'm going to design just this topology in rack. So I need to do what? On switch number 1, first of all I need to up two more interface range f1/0/122, just say no set. Okay, and then on router number 1 I am going to configure one IP address. Interface f1 slash 0/1 0/0, and IP address is 10.1.1.1 Here I have defined the IP address and say no IP routing as well. I have disabled the routing. R2, here also I am going to configure one IP interface f0/0. IP address is 20.1.1.1 255.255.255.0 and say no IP routing. On router number 3, interface f1 slash 0/1. IP address is 10.1.1.2 255.255.0 and no IP routing. Your PVST is done. PVST is done. This is the only concept of PVST, that here we have multiple instances. For each VLAN we have a separate instance. IP address 20.1.1.2 255.255.255.0 and no IP routing. Okay, now on switch number 1 I am going to put router number 1 in VLAN 5 interface f1/0/1 switch port access VLAN 5 and interface f1/0/2 switch port access VLAN 10. On switch number 2, interface f1/0/3 1/0/3, sorry, so CDP neighbor. Routers are not neighbor. I think here I have not run no set command. Interface range f1/0/3 to 4 and say no set. And interface f1/0/3 switch port access VLAN 5 and interface f1/0/4 switch port access VLAN 10. Done. Configuration is done. Is topology clear to all? Is guys topology clear? Nirav,
Yes.
Mohan? Yes.
Yes,
Now
sir.
if R1 will ping to R3, switches are going to use which link? When R1 will ping to R3, switches are going to use which
19.
link?
Yes, sir.
19.
Yeah.
Rapid spanning tree.
Rapid.
RSTP. RSTP stands for Rapid Spanning Tree Protocol. Spanning Tree Protocol. It is an open standard protocol. It is open standard. Open standard. Anything else? Convergence is very fast. Convergence is very fast. This is the biggest advantage of RSTP. And convergence is similar like, convergence in MST is also similar like RSTP. There is no any change in the convergence of RSTP and MST. So if you will understand the convergence of RSTP, that means you have understand the convergence of MST also. Okay. So at the same time, I am going to discuss both protocol. After that, here also we need to enable port fast. Port fast is still required. Port fast is still required here. Then port fast should be configured on access ports. It maintains single instances. It maintain single instance of STP. That is also good thing. Okay, so RSTP is an open standard protocol, and if I will talk about, this is for non-Cisco devices, and if I will talk about Cisco devices, so Cisco have again one separate protocol which support load balancing. That is RPVST plus. Okay, so difference is like, the difference between CST and PVST plus. CST does not perform load balancing and PVST plus supports load balancing. CST maintains single instances for all VLAN and PVST maintains multiple VLAN for multiple instances for multiple VLAN. In the same way, RSTP maintains single instances and RPVST maintains multiple instances for multiple VLAN. Okay. After that, if I will talk about the port state, port states, port states in case of RSTP. So in STP, as you know, we have disable, blocking, listening, learning, and forwarding. In RPVST, disable, blocking, and listening is combined in a single state that is called discarding. Discarding. The second state that we have in RSTP is learning state. And again in learning state, it will spend how much time? 15 seconds. Ports will spend 15 seconds in learning state. If you are thinking that if it will again spend 15 seconds in learning state, then how convergence is fast? So just wait, guys. See. After that, in discarding a state also it will spend 15 seconds. By the way, here also it will spend 15 seconds. And discarding state will show you blocking state, right? It will show you blocking. Okay, but that will be discarding state. So discarding port will spend around 15 seconds in discarding state and around 15 seconds in learning state, and after that forwarding state. Forwarding state. Okay, so we have only these three port state in case of RSTP. If I will talk about port role, port roles, so here we have alternate port, and as you know, alternate port is backup of RP. Then we have one more port role over here, that is backup. And backup port is backup of DP. After that, RP, and then fourth one is DP. So hope till here all the things is clear to all people, because these are similar like spanning tree protocol which we already discussed. Now the main thing about RSTP protocol is BPDU. Just understand the BPDU. BPDU. Guys, if I will discuss about the content of BPDU, so can anyone tell me the content of BPDU in common spanning tree protocol? If I will talk
root
about the content of BPDU, yes,
uh, root root switch ID, bridge ID, root bridge ID.
okay, root breeze ID, very good. Then we are talking
Then
about important information inside the BPDU only. Otherwise, version is also there, protocol is also there, type is also there, right?
sender
After that,
bridge ID.
sender breeze ID. Before that, you should say root path cost.
Oh yes, root. Yes, yes, fast.
Root path cost. Then sender
Then
breeze ID.
sender. Yes. Then
Sender
port priority.
breeze ID. Then sender
Sender port priority.
port ID.
Yes. Yes, port
Send
ID.
port ID. Then after that there will be message time, message is forward delay. But there is one more important field, that is flag. Yes or no? Flag field. How many flag we have? 8 bits. We have 8 bits. Let me talk about the flag in detail. We have 8 flags. Number 1 is 0 bit, first bit, second bit, third, fourth, fifth, sixth, seventh, eighth. Right? These are the 8 flag. Okay, guys, if I will talk about this flag, 0 bits, first bits represent what we had discussed this in, by the way, common spanning tree protocol also. That's why I'm asking you. This bits is used for topology change, TC, and 7th bit is used for TC ACK. Whenever root bridge will receive any TC and BPDU, it will on these 2 bit, TC bit and TC ACK bit. Yes or no? It will on these 2 bit, TC bit and TC ACK bit in their BPDU. We had discussed these 2 bits, this 2 flag in CST, in common spanning tree protocol. Yes or no? Anyone have confusion in these 2 bits, in this 2 flag? Flag number 0 is used for topology change. Whenever root bridge switch will receive TC and BPDU, it will on this bit. And in their first BPDU, after receiving TC and BPDU, it will on TC ACK bit also. But we have some more bit over here. Now we need to learn these bits. If I will talk about the second bit, that is 1, bit number 1 is, bit number 0 is TC, bit number 1 is the proposal bit. This is proposal bit. Okay, and bit number 2 and 3, bit number 2 and 3 is used for port roll. These 2 bits is used for port roll. These these two bit these two bits is used for port roll. Port roll means, we will discuss about this, just wait. Port roll, and this bit is also for port roll. After that, if I will talk about this bit, fourth, fifth number bit, bit number 4. This bit is used for states, learning state. This is for learning state. If a port is sending BPDU in learning state, then it will on this bit. After that, this bit is also for port state, and this is forwarding. And the sixth bit is the agreement bit. This bit is agreement bit. Okay, now question is, why we have these two this two flag for port role. Okay, understand guys this first. Okay, see, if port number bit means flag number 2 and flag number 3, if this is 0 and 0, 0 0, if both bits is off in BPDU, that means port role is 0 0 is, by the way, unused. It is unused. We are not using it. 0 0 is unused for you. Just don't think about this two port. But if second number bits is 0 and third number bits is 1, if second number bits is 0 and third number bits is 1, that means port role is alternate. Port role is alternate. If this bit means second bit is 1 and third bit is 0, that means port role is root port. Root port, RP. RP port will on these two bits, means this bit will be 1 and this bit will be 0 if RP port will send any BPDU. After that, if both bit is 1 1, second bit as well as third bit, then it is designated port. Designated port, that is DP. What I am saying, just we have discussed two flag. We have 8 flag in the BPDU. Out of that flag, 0 flag is for TC, 7th flag is for acknowledgement, 1 flag is for proposal bit, and 2 flag and 3 flag is reserved for port role. 4th flag is define the states like learning state. 5th flag define the forwarding state, and 6th flag is define agreement bits. Okay. When both switch will come up, both switch will think that I am root bridge.
Yes.
Port role of both switch will be DP.
BP.
So both switch will send BPDU. It will also send BPDU. It will also send BPDU. In their BPDU, it will send first of all proposal bit on. It will on this bit proposal. That's why we are saying first time when switch will come up, it will send one proposal. That is not proposal. That is proposal bit on BPDU. It will also on proposal bit. And as I told you that bits 1 and bits 2 and bits 3 is defining what? Port role. So port is DP. So DP port means both bit will be what? 1 1. Here also 2 number flag and 3 number flag will be 1 1. In this BPDU also 2 number flag and 3 number flag will be 1 1. Proposal flag is 1. After that 2 number flag is 1. 3 number flag is 1. Right? In the both BPDU. Am I right? Am I right? Okay. Now let's say MAC address of this switch is 0A and MAC address of this switch is 0B. Which switch will send superior BPDU? Switch number 2 will receive superior BPDU. On switch 2 will receive superior BPDU. Guys, in RSTP, just keep in mind these three things. Whenever a switch will receive superior BPDU, whenever a switch will receive superior BPDU, it will perform three tasks. It will perform three tasks. Task number one is, first, the receiving interface will become RP. First task, receiving port will become RP. After that, second task, it will perform synchronization. Means except the receiving port, except the report where it is receiving superior BPDU, it will put all ports in discarding state. Let's say here this switch is connected with one more switch and maybe with more computers here. So it will put all ports except this receiving ports in discarding state. This is synchronization. It will perform whenever a switch will receive superior BPDU in RSTP. It will perform three tasks. First task is the receiving interface will become RP, and it will perform synchronization. Synchronization means it will put all the interface in discarding state except the receiving interface. And the third task that it will perform is it will send one agreement bits on BPDU. Agreement bits on BPDU. Agreement. And whenever a switch send agreement BPDU, that port will come in forwarding state immediately. Oh my god. Here is the convergence. Because switch 2 is sending agreement, okay, from this interface will come in forwarding state quickly, and whatever switch port will receive agreement bits on BPDU, that ports will also come in forwarding state quickly. So now when switch 1 will receive agreement over here, agreement bits on BPDU over here, this port will come in forwarding state quickly. So this is how switch 1 and switch 2 is going to converge their topology in microsecond, in nanosecond, quickly, immediately. Why? Because there is concept of proposal and agreement. Now if you are thinking that, okay, if this port is in forwarding state and this port is also in forwarding state, what about this port? What about the user interfaces? Guys, that's why we have port fast for user interface, and between switch 1 and switch 2 also there will be agreement and proposal. These two ports will also come in forwarding state quickly because of agreement and proposal. But LAN interfaces are in discarding state. It will put all the interface in discarding state. So these ports will come in forwarding state after 30 seconds. That's why we have port fast. Getting my point? So like here you can see, first of all I am going to do one thing. Between switch 1 and switch 2 I am going to remove one link. Here, where is my, yes, here it is. Between switch 1 and switch 2 I am going to remove one link, that is, let's say, link number 20. Interface F1/0/20 and say shutdown. On switch number 2 also I am going to say shutdown to 0/20 port. Interface F1/0/20 and say shutdown. Fine. Here if you will see, on switch number 1 we have a spanning tree protocol. So a spanning tree, we have some LAN port also. I am going to delete VLAN as well. No VLAN 2 to 10 and interface F1/0/1 switch port access VLAN 1. After that on switch number 2 also, and we have one more port, interface F1/0/2 switch port access VLAN 1. On switch number 2 interface F1/0/3 switch port access VLAN 1 and interface F1/0/4 and switch port access VLAN 1. Okay. Okay, now on switch number 1 let me check a spanning tree. So a spanning tree is running, and these two interfaces are access port, and this is the link between switch 1 and switch 2. Fine. Here I have switch 2. I am going to down interface 0/90 also for some time. I'm going to say interface F1/0/19 and shut down. I will up this interface later after enabling RSTP. So a spanning tree, mode, and R rapid PVST. On switch number 2 also I am going to say a spanning tree, mode, rapid PVST. And now I am going to up interface 0/19. Do so a spanning tree. Here you can see in a spanning tree we have only these two ports, and both ports are in learning state. We are running RSTP, not PVST, right? RPVST. These ports are in learning state. After some time this port will come in forwarding state. Now I am going to up interface between switch 1 and switch 2. Interface F1/0/19 and say no shutdown. No shutdown, and so a spanning tree. See, port will come up, first port will come up 0/19. Just wait. I have disabled this port on switch number 2 also, I think. No, here we have not disabled the port 0/19. So CDP neighbor. Router 1 and router 2 is only neighbor. Wait, do so interface status include connected. Okay, 0/19 is down over here. Okay, interface F1/0/19 and say no shut. Okay, and I have run no shut command, and on switch number 1 if you will check, one port will come up, you will check a spanning tree protocol, you will see that these two ports will goes in blocking state, discarding state, because switch 2 will perform synchronization. Switch 2 will perform synchronization. What happened? Interface F1/0/19 say no shutdown. No shutdown. And on switch number 2, so a spanning tree. Okay, now port is up. You can see these two ports are in. This port is in forwarding state quickly, and it have put these two interface in blocking state. Now these two ports will take 30 seconds to come in forwarding state, but this port is in forwarding state quickly. Yes or no? Have entered in forwarding state quickly. Why? Because of proposal and agreement. If you want to see again, I am going to down interface F1/0/19 say shutdown here, and I will run no shut command. Before that I am going to debug a spanning tree protocol. Debug a spanning tree events. We have enable the debugging. On switch number 1 also I am going to enable the debugging. Debug a spanning tree events. Okay, and now on switch number 2 I am going to run no shut command. Interface F1/0/19 and say no shut. So a spanning tree. In so a spanning tree you can see these two ports are okay. Now port have come. Here you can see the log message, and so a spanning tree. So a spanning tree, you can see these two ports are in blocking state and this port is in forwarding state. And now you can read the event message. When this port was come up, it was sending proposal only. Proposal means proposal bits on BPDU. But switch 2 is not root bridge. It will receive superior BPDU. What happened? Here I think I have some problem. This interface is designated port. Okay, initializing port 1/0/19. 1/0/90 is not designated port. See, when port will come up, first port will become DP, designated port, translating proposal on fast Ethernet 1/0/19. After that, uh, line protocol, this is the log message transmitting a proposal from fast ethernet 1/0 slash, it is sending proposal because it is not receiving any bpdu from their neighbor, but it have received what? Agreement. It have received one agreement, and once it will receive the agreement, ports 0/90 port of switch 1 will enter in forwarding state quickly, and on switch number 2 is sending only proposal, and here we are not able to see agreement bpdu because switch 1 have received agreement on fast ethernet 1/0, but here should be one log message that transmitting agreement. I think here we have missed the message on the top. Initializing fast ethernet 0/19 port, after that this port is designated port, that is fine. Transmitting proposal, that is also fine. And receive superior bpdu, here you can see it have received the superior bpdu on fast ethernet 1/0/19. After that, once it have received the superior bpdu, this port have become what? Root port, and performed synchronization. It have put these two ports in discarding state. Synchronization on port number 1/0/3 and 1/0/4, which is LAN interfaces, and then synchronized. This interface have synchronized quickly, and after that transmitting a agreement on 1/0/19 as a response to a proposal. This is the process, guys. Okay, is it clear now?